Hello everyone, this is Jeffrey, Alpha Delta 7, Lima November, and welcome back to my radio room. Today will be the first installment of what I like to call Elmer Time, where I throw a little bit of information out there to those that need it. And yeah, let's see how it goes. Hope you like it. Here we go. We're going to start off the Elmer Time with something really easy. And let's start off with communications audio. We'll just touch on a couple of things, maybe three things. And we'll go from there. How are we looking on camera? Can you read that all right? Is that penmanship a little small? I may have to go a little larger here. Anyway, two-way communications audio is in no way the same as commercial broadcast radio. In both receive and transmit, two-way radio does not have the fidelity, the audio fidelity that your local AM or FM stereo stations do. And this is by design. Once we figured out that a narrow band of audio could be used to accomplish back and forth radio transmissions, it just became a standard in the manufacturing of two-way radio. And this is the case even today in HF transceivers for AM and sideband. But is there room for improvement without internally modifying an FCC type registered radio? Yes, there is. Of course, you want to make sure that your microphone gain is set properly and you're not using any speech compression, because that's not needed. But after that, yeah, and why? What would be the reason to improve communications audio between one radio and the other? Well, clarity. Be able to read and copy and hear the station speaking to you from wherever they're at over airwaves and vice versa. That is the number one priority for two-way radio communications. It's not to be a high fidelity station like an FM stereo broadcast station where you're hearing the highs and the lows of the music playing. That's just how it is. Now, let's see here. Now the same applies not only for transmission but also for receive. The person on the receiving end of that transmission that you're transmitting to, having the ability to improve and change the audio quality of that received signal will produce more clarity and intelligibility of the voice heard on the transmission. By raising or lowering, or I could say by boosting or subtracting certain audio frequencies within the audio of that transmission, you can gain a positive effect that can occur, leading to the easier copy of voice signals. Now, let me play a quick slideshow for you here to show you what I'm talking about. Now, as you can see here on this scale, human hearing is from 20 hertz up to 20,000 hertz. That's just a standard. There may be some variance depending on the human being, but just as it goes here, this is the standard. Now, if you look at the next part of the slide here, it'll show you the transmitted voice frequency that will be on radio broadcast for two-way radios is from about 300 hertz to 2,800 hertz. So it's a much more narrow band. And that's a standard for basically your HF single sideband radios, their capability of transmitted audio bandwidth, plus or minus, a little bit here or there. Now, as you're going to see here, human hearing is the most sensitive between 2,000 and 4,000 hertz. So what if we were to adjust, either the microphone or the receiving end, the audio output of that receiver, to peak somewhere between 2,000 and 4,000 hertz to make the voice a tad clearer? It seems that studio people dealing with recording music, they will use an equalizer to cut voice between 2.5 and 4K. That's 2.5K and 4K. To soften the voice, to dampen the voice so that the vocals are under the musical instruments. So what does that tell you? That's a professional thing that they do. So it seems that the sweet spot for enhancing audio for two-way radio, both transmit and receive, is to add a bit of audio gain between 2,000 and 4,000 hertz, and subtracting some gain at everything below 300 hertz. So let's bring us back to the Elmer time dry board. Okay, on with the show here. So there are two things to note here. Number one, microphones. Now there are microphones being made for two-way radios now that have an actual peak or enhancement at the 2,000 to 3,000 hertz area, or the audio range, and it's allowing for crystal clear, articulate vocalization over radio waves. They are being made now. Also, for the receive end, there are a few manufacturers now that are making what's called it's called a parametric equalizer. And what this does, it allows for adjusting and enhancing the receive audio of transceivers at the 2,000 to 3,000 hertz range, and reducing gain on other audio frequencies that doesn't need to be in the received audio of the two-way communication. Now, let it be also known that parametric equalizers can be used on shortwave radios, receive-only radios. So for those shortwave listeners that want a little bit better audio, want to pull out some of those weak signals on far, distant worldwide broadcast communications, there you go. Okay, speaking of communications audio, there's a true enemy of receiving radio communications, and that would be radio noise, or sometimes just called static. Kind of sounds like white noise, like those white noise machines that people buy just to listen to while they go to sleep. Don't know why. When I hear it for a long period of time, it just drives me nuts. But I'm a radio operator, so I don't like listening to it that much. Radio noise can cover up or interfere with a radio transmission, a weak radio transmission. And there are two main sources of radio noise. There's man-made, and there's atmospheric. And let's see here. Okay, yes. Well, there's also a couple of other sources of radio noise, such as another man-made radio interference where a man is actually transmitting on another radio, interfering with your receive of a station that you're trying to hear. Also, there's what's called internal radio noise, such as thermal noise. But man-made radio interference through another radio and thermal noise, that's another subject at a different time. So let's just stick with these two, and I'll give you more of an in-depth on both of these, starting off with man-made. So let's show you a quick list of some of the man-made radio noise makers. Here you will see a multitude of man-made radio interfering devices, not intentionally made to interfere with radio, however they do. And this isn't a complete list. This is just a quick list that I actually found on C. Crane's website. Thank you to C. Crane. That gives you kind of an insight of just about anything that you plug into a AC mains could have the could have the possibility of actually making some RF noise and messing with your receive on your radio. So anything that is electrically powered could be subject. And let's bring it back, and I'll talk about some of the atmospheric. Okay, so we touched real quickly on man-made. And atmospheric sources. That could be lightning. It doesn't even have to be lightning in your area. It could be anywhere in the world lightning. Meteors, meteorites, meteorite showers. overcharging of the magnetosphere, the lines of the magnetosphere. Radio propagation. When radio propagation increases in your area, not only does it bring the worldwide signals in, but it also brings more noise from around the world to your radio. So you have to battle the noise level from that as well. Now, are there ways to lessen the effects of radio noise at your station? Yes. There have been many improvements since the early days of radio, and we've been battling radio noise from day one, trying to figure out how to get rid of atmospherics and man-made noise so that we could just pull in the two-way radio signal, the voice. And I've got a list here. It'd be too long of a list for me to write out, but I'm going to read it off here. Your basic audio filters, noise limiter circuits, noise blanker circuits, digital noise reduction, digital signal processing, both in the audio circuit or in the IF circuit. The IF circuit's going to be better for DSP. You've got bandwidth, IF shift, IF width, notch filter, contour filter, RF gain, attenuator. Also, a horizontal polarized antenna. That'll drastically reduce RF noise in most cases, such as your standard dipole, a Yagi, or a sloper. Don't forget to ground your station. That also takes some noise out of the situation. Now, there are two most unused controls on HF or shortwave radios. That need to be used in order to get rid of noise. It's on most of the radios out there, but nobody seems to use them. One being the RF gain. Two being the attenuator, if there is an attenuator on the radio. If not, RF gain. Just these two controls can be adjusted properly, minutely sometimes, adjusted properly, to reduce most of the RF noise while still perfectly receiving the voice transmission. And don't worry about what the S meter reads on the radio. The S meter is nothing. The S meter is just a relative signal indication device. Don't even look at it when you're adjusting for voice, your transmission versus noise. Close your eyes and adjust the RF gain as you're trying to pull in that signal and to block out some of the RF noise. If the volume starts to decrease a little bit while you're doing this, bump up the volume. Go back to the RF gain. Do the fine adjustment till you get just the right spot where you can perfectly hear that other radio transmission, that voice coming to you with an incredibly less amount of RF noise, static, man-made, or atmospheric. So, at that point, I can actually say, congratulations, you just became a radio operator. You actually used the radio. So, if I were to give you homework, I would say, hey, turn on your HF rig, your shortwave radio, start using that RF gain in the volume control. If it has any other kind of noise limiting devices, try them out. Sometimes some of the noise limiting devices are a hindrance on certain modes, such as sideband, AM or FM. you just have to work through each different kind of device and see what works best. So I guess with that, I'll just catch you later, and I appreciate the time that you've spent with me here on my first Elmer time. Sorry for the awkwardness. This is a little new for me, but it'll get better. I'm sure we can have some fun with some of the topics, and we'll do this again. So you guys have a great day. This is Jeffrey, Alpha Delta 7 Lima November, and I'm Claire. See you later.